One of my favorite books is The History of Mathematics by D.E. Smith. It's over 1,000 pages and there are 2 volumes, and in my opinion, it is a masterpiece of scholarship. I highly recommend it. But come on, let's be honest. You don't have 1,000 pages worth of patience today. You're here for the synopsis, right? So this podcast, spoken off the cuff, is the espresso version. Here we go. Nope, sorry, wait. First, a word from my advertisers. Before there were calculators, pencils, or even pockets to lose pencils in, there were humans. They had 2 urgent questions. 1, is that berry poisonous? And 2, how many goats do I have because the goats keep leaving? Now, we don't know if early humans invented numbers to count goats or to count the times the goats escaped. Either way, they needed a system, and by system, I mean a stick. They carved little notches in bones and sticks. Congratulations! You are listening to The Birth of Accounting. The first ledger is a bone. No monthly subscription required. If you've ever tried to count sheep, you know the problem. Sheep move. They drift in and out of the frame like fuzzy clouds with opinions. Early humans discovered a genius hack called one-to-one matching. Touch a pebble for each sheep. If you run out of pebbles, you have more sheep than pebbles. And if you run out of sheep, you have more pebbles. It's elegant and dusty. But soon a pattern appears. 10 keeps happening. Fingers are extremely persuasive. 10 is handy because hands are handy. But our ancestors were creative, so sometimes they counted to 20 with toes. That gives us base 20, which is a vibe in parts of the world. If you have ever said score to mean 20, you are doing toe math in a tuxedo. Other groups like even bigger bundles. In Mesopotamia, traders and scribes worked with 60s. Why 60? Well, 60 is kind of polite. It divides many numbers, which makes fractions friendlier. Also, nobody wants to slice a pizza into 7 equal parts. 60 says, I got you. It is why your minute has 60 seconds, not 100. Thank you, Mesopotamia. Our watches are weird because your fractions were excellent. Now, let's talk about this whole base 60 thing. How on earth did Mesopotamians decide to count all the way to 60 when the rest of us are content with fingers and toes? Well, here's the trick. They didn't just count fingers, they counted phalanges. That's the fancy word for finger bone. Each finger, not the thumb, has 3 little sections. Use your thumb as a pointer and suddenly each hand gives you 12 spots to tally. Multiply by 5 fingers on the other hand and boom, you've got 60. That's clever, it's practical, and it's probably the only time your thumb got promoted to human abacus. While numbers are learning to walk, language is teaching numbers how to talk. Words like 1 and 2 hitch a ride on breath and memory. Some languages even have special counting words depending on what you are counting. Fish get 1 set of words. Long objects get another. Goats probably got their own because goats insist on special treatment always. Now, while the math of how many is getting sorted, something else is happening at the campfire. People were looking up because the ground kept changing. Rivers flooded, herds migrated, seasons refused to send email reminders, but the sky is gloriously punctual. The sun rises where it should, sets where it must, and the moon cycles like a gentle metronome. If you want to know when to plant barley, or when the fish return, or when your in-laws traditionally visit, the heavens are a calendar that doesn't forget its password. Enter astronomy. First, it is just noticing. A bright thing rises here in the winter, another bright thing rises there in the summer. We should mark that rock. Rock gets marked. Then someone says, hey, if we put 2 stones here and 1 over there, the sunrise on a certain day will peek right through. Now you have an observatory and a tourist attraction. Please bring snacks. From 5000 BCE in Mesopotamia, we get records on clay tablets that tie sky events to earthly life, like eclipses and the motions of planets. Over centuries, they turned notes into tables, which were the ancestor of spreadsheets. but with more cuneiform etchings and fewer macros. From Egypt, the Nile's rhythm and the appearance of Sirius helped anchor calendars that could reference floods, planting, and harvesting. The stars were not decoration. Priests tracked rising stars called deacons to tell time at night. From China, they saw long traditions of sky watching. Court astronomers kept careful logs because emperors cared about omens and calendars. And frankly, they also cared about punctuality. So if the calendar slipped, tax day showed up on the wrong Tuesday, and nobody wants that. So they audited the sky. Do you notice the feedback loop? The more you watch the sky, the more you need numbers. The more you use numbers, the better you get at predicting the sky. They invented better counting. They invented better symbols. Eventually, they invented the recipe book of the universe, also known as mathematics. And they passed it on with clay, papyrus, bamboo slips, and whatever your local stationery store carried in 2000 BCE. So, back by the goats, our hero, math, was upgrading. The tally stick got columns for different herds. Maybe small notches for kids, larger notches for adult goats. It was a positional idea in the wild. And so in time, shepherd math met market math. And they had to figure out how do they divide these. And so fractions appeared. Everyone sighed, and the Mesopotamians brought 60 to the party. So the slicing was nicer. Scales of 10, scales above 10, scales of 20. You could pick your favorite. It was kind of like an a la carte for math. And by then, humans had two superpowers that loved each other: pattern hunting and storytelling. Pattern hunting said, the moon grows and shrinks, there must be a rhythm. Storytelling said, we should name that rhythm and sing about it. Soon mathematics was in myths, rituals, architectures. It had become a way of life. It was baked into when you planted, how you traded, and where you built the doorway, and which night the whole town met to watch the sky do a trick. So, prehistoric mathematics was not homework. It was a lifestyle. It was goats and grain, stars and seasons, pots and patterns. It was fingers, toes, and a very charismatic number 60. It was the moment we realized that the world liked to repeat itself if you paid attention. And once you noticed repetition, you could predict things. Once you could predict things, you could relax until the goats escaped again. Coming up next, we trade bone notches for clay tablets and step into the river valleys where writing, measurement, and math started wearing real shoes. Bring your stylus and maybe a spare pebble for old time's sake. We'll be right back after a quick word from my advertisers. After our goat counting, we stepped into the historic period down to 1000 BCE. And by now, humans were doing something revolutionary, not just noticing patterns, but writing them down. In the Stone Age and Paleolithic Age, mathematics was simple. They would say, that's a lot of bison, or that's not enough berries. But eventually we graduated from scratches on bones to scratches with meaning. And by around 4000 BCE, the advent of writing turned math from finger wiggling into something permanent. Clay tablets and inked bamboo slips meant you could keep score without actually having to be there. The world's first group project in history had begun. And unlike modern group projects, at least this one got finished. Meanwhile, in China, mathematics was already flexing. Certain historians believe that some of the first descriptions of astronomy go as far back as 3000 BCE. Early Chinese thinkers were using numbers in governance and divination. The legendary I Ching, also known as the Book of Changes, was a mashup of philosophy, mysticism, and binary math before binary math was cool. By the 8th century BCE, under kings like Wu Wang, often translated as Wu of Zhu, China was formalizing rituals, governance, and record-keeping. Numbers weren't just handy, they were political tools. Then we come to the legendary Huang Ti, the Yellow Emperor. Chinese tradition credits him with inventing all sorts of useful things, like medicine, music, even government structure. And woven into these myths are the seeds of mathematics as canonized knowledge. Eventually, Chinese learning was framed around the 5 classics, with the I Ching among them. It was proof that math was not just for merchants and scribes, but part of the state's intellectual DNA. Meanwhile, in India, Hindu mathematics was stirring. From the early Vedas to the later treatises, numbers shaped rituals, altars, and calendars. Geometry told you where to place the sacred fire, astronomy told you when to light it, and arithmetic told you how much food you'd need to keep the priests happy. One of the most famous astronomical texts, called the Surya Siddhanta, would eventually appear in its first form, offering trigonometry, planetary motion, and calendar rules. Not bad for a handbook with a title that translates roughly to Knowledge of the Sun. Across Persia, India, and their neighbors, knowledge cross-pollinated. When your trade routes included camels, spice caravans, and the occasional invading army, ideas tend to travel. Math was portable, kind of like a good joke. All right, let's march back to the fertile valleys of Mesopotamia and Babylonia. Around the Tigris and Euphrates rivers, scribes pressed their first cuneiform tablets with columns of numbers. The Chaldeans, keen sky watchers, combined mathematics with astronomy. They were tracking eclipses and predicting omens. So if you've ever opened an Excel file called budget_final_final in all caps _ this one is the final, I think you understand their energy. Clay tablets filled the shelves, recording everything from goat counts to planetary movements. And by the way, some of those earliest math tablets are 4,000 years old, and they are still readable. Meanwhile, I still can't open a Word document from 2003. Then there's Egypt. By the 3rd millennium BCE, Egyptian engineers were doing geometry with precision that would impress your high school math teacher. They designed pyramids, surveyed farmland, and used sundials to keep time. Forget daylight savings. Egyptians had sunlight accuracy. The great pharaoh Ramses II even divided land among his people, which meant mathematics wasn't just for pyramids. It was also for property disputes. Picture the court. Yes, your majesty, we measured your cousin's field 3 times, and no, he cannot count the neighbor's goats as his own. Yep, I could hear it. From Stone Age scratches to Egyptian sundials, mathematics had gone from survival skill to statecraft. The world was realizing that math wasn't just about tallying sheep, it was about running civilizations. And that realization leads us westward into the world of the Occident, where philosophers, merchants, and would-be mathematicians were about to take center stage. Occident simply means the West, and the place where the sun goes down. Its opposite is the Orient, the East, where the sun comes up. Basically, a poetic way to say sunrise over here, sunset over there. In the Occident, math got philosophical. The Greeks weren't satisfied just counting sheep. They wanted proofs. They wanted reasons. They wanted to argue about numbers until everyone else at the symposium pretended to fall asleep. And then came Pythagoras, the guy everyone credits with discovering that right triangles have a thing for squares, except he did not discover it. Babylon and India had already been doing that math for about 2,000 years. So what happened? Well, Pythagoras just slapped his name on it. So technically, math is like comedy, and the Pythagorean theorem is the oldest borrowed joke in the book. So while Pythagoras was busy with triangles, the Chinese already had rods, shadows, and proof sketches. Think of them as the silent backup guitarists in the global math band. In India, they were messing with string, bricks, and fire altars, making precise right angles thousands of years before Pythagoras could trademark the idea. So Pythagoras is kind of like the Spinal Tap of math, always leaning into the common cliches. I could see that. Okay, so then there's Plato, who said that math was the language of perfect forms, triangles, circles, cosmic ideals, lounging in some celestial VIP room. And Aristotle, who wrote down rules for logic and classification, basically invented the world's first math-adjacent BuzzFeed listicles. So that's the Occident, proofs, philosophy, and the first math club with actual membership rules. But the sun doesn't just set, it also rises. While the Greeks were busy arguing about triangles, the Orient was quietly doing math of its own, often with a lot less drama and a lot more practical results. In China, the Zhoubi Zhuanjing gave us the Gouju theorem, which yes, is basically the Pythagorean theorem, except a few centuries earlier. They also had counting rods, little sticks arranged on a board that let you do place value arithmetic, negatives, and even fractions. Basically, the world's first calculator app, but in wood. Over in India, the Shulba Sutras showed priests laying out fire altars with ropes and pegs. And wouldn't you know it, right triangles kept showing up. They knew their 3, 4, 5 triangles long before Greece tried to trademark them. So while Western history textbooks sometimes made it sound like Pythagoras invented everything, Pythagoras, 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 Marcia, Marcia, Marcia. The truth is, the Orient was already playing the same game. They just weren't as noisy about taking credit. They were quietly and diligently doing their homework. So after the Greeks had their fun proving that triangles weren't lying to us, mathematics packed its bags and moved to Alexandria. Picture a university/library/nerd paradise. I can. Shelves of scrolls, scholars scribbling everywhere, and enough papyrus dust to choke a camel. It was the beginning of paperwork. Yay. At the front of the class, Euclid. He wrote The Elements, a math textbook so good it outsold the Bible for centuries. No joke. Every proof, every theorem laid out like IKEA instructions for the universe, except his triangles actually fit together at the end. Then there was Archimedes, the inventor, the mathematician, the engineer, and basically an all-around show-off. You know, the overachiever who tries so hard for the sake of trying, who just wants to do better than everybody else, but really feels isolated inside, okay? He calculated pi, he built war machines, and he supposedly ran naked through the streets shouting Eureka after figuring out how to measure volume in a bathtub. That's right. The greatest breakthrough in fluid mechanics began with public nudity. And we have Pythagoras. Nope, we have Archimedes to thank for that. Pythagoras, Pythagoras, Pythagoras. Speaking of astronomy, Ptolemy. His Almagest gave us a geocentric model of the universe with the Earth at the center. It was complicated, elegant, and totally wrong. But hey, it lasted for 1,400 years, which means either he was convincing or nobody wanted to redo the math. And I'm going to lean into the latter because I actually did a podcast about that way back in 2020, I think. Then comes Diophantus, the father of algebra. He loved equations with whole number solutions, what we now call Diophantine equations. It was the kind of math that looks innocent, but can actually ruin an entire Saturday. And centuries later, I kid you not, Fermat would scribble in the margin of his book something along the lines of, I've got a proof for this, but the margin's too small, which is basically the mathematical equivalent of a mic drop. And then my personal favorite, Hypatia of Alexandria. She was a brilliant teacher, a philosopher, a mathematician. She taught geometry and astronomy. She edited her father's works and wrote commentaries that preserved Greek math for future generations. She was admired by students, respected across the ancient world, and tragically was murdered by a mob of monks in 415 CE. Her story is why I wrote a book about her, because history should remember not just her death, but the sum of her life and legacy. And that actually happens to be the title of my book, called Hypatia, The Sum of Her Life. And you can find it on Amazon, and the link will be in my show notes. We'll be right back after a quick word from my advertisers. Here's what's interesting. After Hypatia was murdered, things got weird. And about 100 years later, the West hit pause. Europe slipped into the so-called Middle Ages, where math mostly huddled in monasteries, trying not to be forgotten. It wasn't a total blackout, just a very long math nap. Luckily, while Europe was dozing, the Islamic Golden Age was wide awake. Scholars across Baghdad, Damascus, and Cordoba translated Greek works and added their own discoveries and gave us new tools. There are even tracings of Hypatia's work in some of the translations from the Islamic Golden Age. Algebra got its very name from al-Khwarizmi. Trigonometry blossomed, algorithms were born, and without them, Europe would not have had anything to wake up to during the Renaissance. In short, while Europe was snoring, the Islamic world was basically babysitting math, feeding it, clothing it, and teaching it how to walk. So, when the Renaissance finally rolled around, Europe didn't invent math all over again. It snuck out the window with Dad's car keys and went for a joyride, taking credit for all the fun. By the 1300s, the great centers of the Islamic Golden Age had dimmed. The Mongols sacked Baghdad in 1258, and let's just say that the House of Wisdom didn't exactly get a renovation budget afterwards. So without strong rulers funding scholars, math and science lost some of their shine. Theology and law were safer bets than astronomy or algebra. And while the Islamic world was arguing over which star catalog to keep, Europe was busy stealing the whole frickin' library. Spain, Sicily, and Crusaders carried translations into Latin, and suddenly the West was cramming algebra like a college kid before finals. And that doesn't mean math disappeared in the East. Far from it. Ulugh Beg and the Samarkand built an observatory so massive it made Stonehenge look like a backyard lawn decor. But the golden age of invention had slowed. The math car keys were now jingling in Europe's pocket. Meanwhile, in China, scholars like Cheng Dewey printed arithmetic manuals that spread like wildfire. Counting rods, abacuses, and math tables went from scholars' desks to merchants' toolkits. Math was basically hitting the shelves like the latest bestseller. Trade routes in the 13th century carried more than silk and spices. In India, Siddhara and Bhaskara II wrote on astronomy, arithmetic, and algebra, predicting eclipses while Europe was still suspicious of zero. Meanwhile, in Persia, Al-Khwarizmi pushed algebra into new territory with powers and roots, laying groundwork for future algebraic thinking. And Chinese astronomical methods even traveled into Japan, shaping calendars and sky charts. So by the 1500s, the Orient had printing, algebra, astronomy, and trade all fueling with mathematics, which meant that when the Renaissance revved its engines, Europe wasn't inventing math from scratch. It was merging into an already busy highway. So, Europe sneaks out with Dad's car keys, takes math for a joyride, and suddenly it's the Renaissance. The printing press is the turbo boost. Math isn't just locked in libraries anymore, it's mass-produced. Textbooks, tables, diagrams, all spreading faster than gossip in a small town. Math memes, but in ink. Enter Francois Viet, whom I've also done a podcast on. Did that about a year ago. Please go visit mathsciencehistory.com and dig around. There's some good stuff there. Anyhow, Francois Viet, he was the guy who gave algebra its makeover. Before him, equations were basically long-winded novels like
the unknown multiplied by itself, added to 4 times the unknown, is equal to 21.
Viet said,
"Nope, let's just use letters."
Suddenly, algebra looked like Twitter. Short, sharp, and easy to argue about. Meanwhile, trigonometry was getting a glow-up. Navigation needed it. And when your ships are crossing oceans,
close enough, right?
Is not good enough. Tables of sines and cosines went into print, and sailors could finally aim for the new world without relying entirely on guesswork and rum. Though to be fair, rum was still heavily involved. The Renaissance also saw a mashup of art and math. Perspective drawing turned flat canvases into 3D illusions. Architects rediscovered geometry, making domes and cathedrals that looked like math problems you'd actually want to live in. So the 16th century gave us algebra with style, trig for sailors, geometry for artists, and math books going viral thanks to Gutenberg's machine. It was less about inventing new math and more about broadcasting it to the masses. I love it. And next, well, things really speed up. The 17th century, where Descartes brings us analytic geometry, Fermat and Pascal invent probability, and Newton and Leibniz get into the world's most famous calculus cage match. It's good. The 17th century was Europe's math fireworks show. France, Britain, Germany, the Netherlands, every country wanted a math genius to brag about. In France, René Descartes invented analytic geometry, turning curves into equations. Suddenly, algebra and geometry weren't two subjects that hated each other in high school. They were dating. In the Netherlands, Christian Huygens studied pendulums and probability, basically building the first math-powered clock and helping gamblers figure out their odds. You gotta know when to hold 'em and know when to fold 'em. In Britain, a certain Isaac Newton came along, invented calculus, and then decided gravity should be his side hustle. Meanwhile, in Germany, Gottfried Wilhelm Leibniz also invented calculus. Cue the most brutal math feud in history, the Newton-Leibniz cage match. In the red corner, from Woolsthorpe, England, the apple dropper, the gravity guy, the calculus crusader, Isaac, don't steal my derivatives, Newton. And in the blue corner, from Leipzig, Germany, the philosopher, the polymath, the notation ninja, Gottfried Wilhelm integrals forever Leibniz. Yep, Newton claimed he invented calculus first. Leibniz said his notation was better. Their fans went to war. Pamphlets, accusations, full-on character assassinations. Newton, who just happened to run the Royal Society, stacked the jury against Leibniz. That's like being both the boxer and the referee. Brutal. Leibniz died with his reputation in tatters. Newton, meanwhile, lived long enough to look smug about it. And yet, both notations survived. Today, we use Leibniz's slick symbols and Newton's methods. Back in France, the 18th century saw the rise of giants like Euler and Lagrange, churning out equations like a bakery turns out baguettes. Theoretical math was the center stage, and this is a really fun era to study. And remember Euclid? His Elements, written way back in Alexandria, was first printed in 1482. So by the 17th and 18th centuries, it was still the gold standard. Imagine writing a textbook that stays in print longer than Shakespeare. Meanwhile, European math didn't stay in Europe. By the 16th and 17th centuries, translations carried these works eastward. Chinese scholars began building essential treatises based on European models. And through Dutch traders at Nagasaki, math also slipped into Japan, where scholars like Nakane Genkai adapted Western astronomy and algebra into Japanese frameworks. So the 17th and 18th centuries gave us analytic geometry, probability, calculus, a feud worthy of pay-per-view, and the first global math exchange program. Not bad for a couple of centuries. So up to now, math had been busy building its toolkit. Geometry, algebra, trigonometry, probability, calculus. Each century added another gadget to the box. By the 19th century, the box was overflowing. And that's when mathematicians decided, hey, let's see how far this thing can go. So remember Descartes' analytic geometry, that marriage of algebra and geometry? By now, it was producing children, whole families of curves, surfaces, and equations. Calculus, invented in the 17th century for physics and astronomy, had grown into a universal tool. It could describe how planets move, how heat spreads, how a pendulum swings. And trigonometry, once about triangles and shadows, was now deeply woven into calculus, making it possible to tackle wave motion, oscillations, and even music. The triangle wasn't just hanging out on chalkboards anymore. It was solving differential equations. The glow-up was complete. Enter the 19th century heavyweights. In Germany, Gauss ate theorems before breakfast. Actually, he didn't eat them, he just solved them. He dabbled in everything from number theory to magnetism and made everyone else feel underachieving. I've been around people like that. It's no fun. His student, Riemann, bent geometry itself, laying the groundwork for curved spaces, a concept that would later fuel Einstein's relativity. Meanwhile, a fiery young genius named Évariste Galois practically invented abstract algebra before dying in a duel at the age of 20. And if you want to hear a podcast about that, I also do one about that as well, which was done about, 15 months ago. So again, please visit mathsciencehistory.com and dig around in the archives and you'll see some great podcasts. And while you're there, click on that coffee button because every donation you make keeps the podcast up and running. Anyhow, back to Évariste Galois. Think of what he did. He created group theory, field theory. It was all sketched out literally in a few frantic manuscripts the night before his last pistol match. Mind-blowing. This kid was brilliant and he was only 20. So yeah, math can be dangerous. Don't get involved in duels. Then comes Cantor, who looked at infinity and said, one size doesn't fit all. He showed that some infinities are bigger than others. And then finally, Emmy Noether, who formalized abstract algebra and tied it to physics. Her theorems still drive modern science. If algebra were a messy teenager, Noether was one who said, clean your room, organize your variables, and respect symmetry, like a true boss. So, by the 19th century, math had evolved from counting goats and proving triangles to taming infinities, curving space, and inventing algebra so abstract it made even mathematicians nervous. And in my case, when I was studying math, it made me cry. I'm going to admit it. It made me cry. It's hard. And just when math seemed to have reached its limits, the 20th century cracked the door wide open, bringing machines that could calculate faster than any human, physics that bent reality itself, and logic that questioned what we even mean by truth. Math wasn't just sneaking out with the car keys anymore. It was hot-wiring the whole garage. Buckle up. Things are gonna get wild. By the dawn of the 20th century, math wasn't just sneaking out with the car keys anymore. It was stealing the whole car, peeling out of the driveway, and never looking back. First up, David Hilbert, the grandmaster of rigor. He laid out 23 problems in 1900, like the ultimate math scavenger hunt, challenging mathematicians to solve them over the next century. Some got solved, some are still haunting blackboards like math's version of the unsolved true crime. Then came Kurt Gödel. He dropped his incompleteness theorem in 1931 and proved that math itself has limits. There will always be true statements that can't be proven. Mathematicians cried. Philosophers panicked. Logic had just punched certainty in the face. Meanwhile, Alan Turing was teaching machines how to think. His work on computation and algorithms birthed the modern computer. Suddenly, math wasn't just in books. It was humming inside machines, calculating, encrypting, breaking codes, and eventually playing chess better than humans. And over in physics, math was bending reality itself. Einstein's relativity used Riemann's curved geometry to show space and time aren't fixed. Then, quantum mechanics arrived with wave functions, probability amplitudes, and equations that said particles could be cats, both alive and dead, until you check. So math had gone from let's count goats to let's describe parallel universes. That escalated quickly.
Goats in space!
Then there was chaos theory. Suddenly, simple equations produced wildly unpredictable outcomes. The butterfly effect became a household phrase, though mathematicians never did prove whether butterflies really control the weather or just have really good PR. As the century rolled into the 21st, math embedded itself everywhere. In cryptography, securing your credit cards, in data science, running everything from Netflix recommendations to climate models, and in AI. So, math has officially taken the wheel. And no, it's not bringing the car back. So here we are, from tallying sheep bones to infinity, from sundials to supercomputers. Math has been our universal language, our secret decoder ring for the cosmos, and occasionally our favorite excuse for why we are bad at taxes. And the ride isn't over. Math began as a baby. It was coddled by the Islamic Golden Age, and then it became a car sneaking out of the driveway, then tearing down the highway, inventing new lanes as it went. But here's the thing. Highways only take you so far. By the 20th and 21st century, math wasn't satisfied with asphalt. It strapped on boosters, pointed upward, and launched. From quantum mechanics to AI, from curved space to infinity itself, math has become our rocket. It's our ticket into the vast unknown. Every equation is a launch pad, every proof a countdown, every theorem a trajectory. And where does it go? It goes into a universe that has no end, no edges, just limitless space for discovery. So math isn't just driving anymore, it's flying. It's carrying us past what we can see, past what we can touch, into the infinite. And the ride? Well, the ride has only just begun. Thank you for listening to Math, Science, History. And until next time, carpe diem. Thank you for tuning in to Math, Science, History. If you enjoyed today's episode, please leave a quick rating and review. They really help the podcast. You can find our transcripts at mathsciencehistory.com. And while you're there, remember to click on that coffee button because every dollar you donate supports a portion of our production costs and keeps our educational website free. Again, thank you for tuning in. And until next time, carpe diem.